I work on Clojure and Datomic. I've been doing that for about the last decade. And we're going to start by talking about design. Design has two dictionary definitions that are relevant for software. One of them is about planning, making a plan for some work that you're going to do. And the second definition is about to decide upon the look and feel. Both of these definitions are completely relevant for software, but we're only going to focus on the first. And because that's a lot of words, we're going to simplify it down to make a plan and write it down. Agility is about speed. Design is incredibly agile because planning is faster than doing. It's faster than coding. It's faster than testing. It's faster than a speeding deployment. It's the fastest thing there is. So, of course, Agile is all about design. Maybe not so much. So the word Agile does not actually appear in the Agile Manifesto. And Agile has worked pretty well. So maybe design is not that important. Everybody loves people and working software and collaboration and adaptability and ice cream and apple pie. So maybe we don't need this design thing. But if you look at the history of Agile and what it was a reaction to, you'll see that there is design in there. Those of you who have worked on a Waterfall project, remember that design happens in year one. Right? Near the top of the chart, you design, and then there's development maybe by a different team and testing by another team, and so on and so forth. And the Agile movement fixes this in at least two important ways. One way is it says that those feedback loop arrows go in all directions. So instead of saying that we're going to have this cascading series of things where a design failure can take years to sort of roll down the mountain and land on people, design can take feedback from development, from testing, from things that are logically, in some sense, later in the cycle. The second thing that Agile does, with words like sprint and iteration, is breaks the process down into much smaller chronological increments. And so instead of having this series of steps take place over years, you have this series of steps take place over days or hours. So that's great. But the manifesto leans you a little bit towards adaptability over planning. It doesn't actually say don't plan, but it does say we're going to prioritize responding to change over following a plan. This is unfortunate, and it's a bad take. And we can get a better take from everybody's favorite Agile coach. This is Dwight Eisenhower. And Dwight said, plans are useless, but planning is indispensable. Eisenhower understood that design and agility are not some kind of zero-sum game. You can do great planning and simultaneously entertain the notion that you will change the plan radically as soon as you encounter new information. So, how did things work out for Agile without an emphasis on design? Not well. If you go to the Wikipedia page for the Agile software development movement, the very first pitfall listed on that page is lack of design. And the choice of the word pitfall is itself ironic commentary on the Agile movement. You've probably heard the joke, how many Agile developers does it take to cross a pit? It takes 4. The first 2 developers fall right in, and the second 2 developers have a retrospective and decide that look before you leap is going to be industry best practice moving forward. So what is design? What are we doing when we do design? Design is about taking things apart. And my colleague Rich Hickey gave a talk at QCon, I believe in 2013, titled Design, Composition, Performance, where he talked about all the different things that you can take apart when you're doing design. You can take apart requirements. You can break them into smaller and smaller pieces. You can find the places where data has to flow in your application and take those apart and order them in different ways. You can take apart the places where things need to happen, and you can take apart the participants and organize them in different ways. You can take the information that your application is going to manage and separate it from the mechanisms that you use to manage it. And you can take apart multiple candidate solutions. Instead of starting on a plan, consider 5 different plans or 10 different plans. And I'm not going to repeat that talk here. It is a 60-minute talk, so it wouldn't fit in this slot. But I encourage you to watch it, and I will give just one example of the kind of thinking that Rich is talking about. So let's imagine that you're designing polymorphism. This is something that's already designed, so we know how it works. For polymorphism, you need 3 things. You need some notion that I'm going to call an interface, which is here's the abstraction of behavior that we want to provide. And you need a notion of implementations. And third, you need a notion of extension. So that's a taking apart of a problem. We've taken apart this, and actually we're kind of taking apart the solution space. Now, in order to put that into a context, we need to assign each of these 3 things a mechanism in our language. This sounds easy, but as of 2019, most programming languages do this wrong. Java, to take one example, Java has a simple mechanism for dealing with interfaces. It has interfaces, but Java has class definitions doing double duty. Class definitions are responsible for implementation, and they're also responsible for extension. And when you have something that you've taken apart and then you deliver it braided together, this is called complecting. It's the opposite of simple, and it's something you want to avoid. Clojure has a designed solution to this problem. It has 3 language mechanisms, 1 for each of these characteristics. Now, if you've been successful writing programs in object-oriented languages, you may think that I'm making some technical academic point here, and it doesn't really matter. I mean, people build stuff in Java all the time. But it matters hugely. And every time you see string utils or anything like that, you're seeing people being adaptive instead of doing design work. Right? String utils are an adaptation to the lack of this feature in a language. So what do you do when you're taking things apart? I'm going to look at several examples of activities that are helpful in taking apart problems and taking apart solutions. The first one is make diagrams. Diagrams got a bad name because of UML. And UML has a lot of problems. This is the sort of class hierarchy for UML. So you see behavior diagrams on one side and structure diagrams on another. And inside behavior diagrams, you could have use cases or timing or what have you. And the problem with this siloing is it's like static typing for diagrams. Your diagram can be a this or a that or a the other thing. And basically what has happened in practice is that UML encourages you to take your thoughts and chop them into smaller and smaller pieces until the pieces that you're working with are too small to be useful. Good design is the opposite of this. When you're taking things apart, you need to have a visual canvas where you can see all the elements that are in play. So here's an example diagram from the work that we did on Clojure 1.10. The feature is called PREPL, although that doesn't really matter here. But the point I want to make about this diagram is it combines things that would be in a half dozen different UML diagrams. It shows multiple subsystems. It shows encapsulation boundaries and seams. It shows the flow of time and the flow of information. It shows function invocations. It shows data formats. It shows free-form notes. What this is a snapshot of somebody working on a problem that captures everything that they need to understand how to move forward on the problem. So it's not adhering to some official guideline for I'm going to make this kind of diagram or I'm going to make that kind of diagram. And in particular, don't copy this. Do not leave this talk and make a diagram that looks like this. Unless you're designing PREPL, that's guaranteed to be wrong. Every diagram can and should be different. And this kind of work is invaluable when you're planning the code you're going to write. And it's invaluable again 5 years later when you have to pick up the code in maintenance. We don't code on the Datomic team without pictures like this in play. So when you're making diagrams, don't be afraid to show different things. Don't be afraid to experiment. And keep everything. We have an incredible update-in-place bias about how we manage design artifacts. If you went through 7 different edits of making diagrams, you should have 7 diagrams that you can go back to and look at later. I understand that the first 6 are not the one that you landed on, but when you're thinking about the problem again 2 years from now, you're going to want to go back and look at those. And we do not have a shortage of bits. Right? There's plenty of storage out there for storing all the diagrams that you want. Erasing is a crime. Also, remember that design is a process, not a product. So the purpose of these diagrams is, sometimes it can later be we're going to communicate to other people about our thought process, but it's primarily about thinking through the issues. And it's perfectly okay to have questions. And often, we don't start coding until we've removed every question mark from a diagram. A second thing to make, this is actually much easier to get started and learn, is tables. When you're considering alternatives, you're going to have alternatives and you're going to have axes of comparison. This is one that I just grabbed at random from Google Sheets, where we were planning a feature for Datomic, and so rows 2 through 8 here are different things that users needed, and we were assessing whether or not we wanted to use AWS VPC link or AWS endpoint service. And this is a very basic idea. Come up with criteria for evaluation, come up with more than one option. Always flesh out more than one alternative before you start to code. If you have not considered more than one alternative, you're not designing. Here's a more elaborate example. And in this case, for intellectual property reasons, I've actually blanked all the cells. But this is the same kind of design process going on, except here, we're considering 9 or 10 different alternatives on 9 or 10 different axes. When was the last time you took the time to consider and write down 10 different alternatives before you wrote code? 10's a pretty high number. I'm not saying that happens all the time, but when that many things are on the table, certainly when you're doing technology selection, you're picking your NoSQL database. There are certainly more than 10 alternatives. Those alternatives have characteristics, and they are going to match up or fail to match up to the thing that you're trying to build. Doing this work is an order of magnitude faster than building the wrong thing. There's no way, I don't care how agile and adaptable you are, there's no way that you can outrace a team that's thinking first by building the wrong thing and then using to figure out that it's the wrong thing and then building something else. So make tables. Consider multiple options. By the way, it's hard to pick the row and column names when you make these tables. And you're often going to find that the problem is not two-dimensional, and then sort of our ability to sort of make things gets challenged, and so you may need to make multiple tables. We often have multiple iterative back and forth arguing about what the columns should be before we even go off and do the analysis. Again, as with diagrams, keep everything. This is actually, you could just be lazy and let Google Sheets or whatever your tool is let you go back and look at things. That's one way to do it, or you can just make copies. But keep everything, don't throw away your thoughts. A third activity that you do when you're taking things apart is writing good prose. And the most important single piece of good prose is a good problem statement. We had a problem in the Clojure community that people were suffering when something would go wrong, they would get a bad error message. Has anyone had a problem that you were writing a program and you got a bad error message from some library or tool ever? Does that ever happen? So it was endemic on the Clojure survey, year in and year out, and the way the problem statement was usually phrased are, wow, something goes wrong and I get a hideous stack trace. And that's fine, and those ill-formed problem statements are the starting point, but this is where the design work comes in. When we actually tackled this problem, we said, where do errors happen? They happen in different contexts. They happen in front of the end user. They happen in front of operational people. They happen in front of developers. They happen in front of testing. I'm not saying those are siloed roles. It could be the same person operating in those different roles. But errors happen in different contexts, and you want different things in those contexts. Then when you look at what an error is, you have data at the location where the error occurred. You have telemetry, stack traces from the language or whatever where the error occurred. Sometimes you have code that's interpreting the error before handing it on to the next stage of processing. Anyone who's done the Java exception that wraps a Java exception that wraps a Java exception that wraps a Java exception, when that's done well, it's actually attempting to add additional information. There's also issues about serializing errors. How are they, how do they cross process boundaries? In addition, there are human consumers of errors, and there are programmatic consumers of errors. If you're writing an IDE, you probably want all that stack trace information, because you're then going to be able to do something useful with it. You're going to be able to filter it, color code it, do additional analysis. If you are an end user, and you made a totally expectable mistake, you're not going to want to see that. And so once we had that information in place, it was possible to actually take on this problem, and it turned out it wasn't about stack traces at all. We had heard that complaint hundreds of times, and the thing that we actually did, we did multiple things, had nothing to do with stack traces. And it started with a bunch of prose that began with a problem statement. And you don't have to be able to read this here, but the first part of the problem statement is people are confused about what the problem statement is here. Here's some of the actual underlying problems, what needs to change. We iterated on the problem statement. We iterated on the principles. We iterated on the proposed implementation changes, all before starting to code. And I'm not talking about something that took months or years. I'm talking about, it's Agile, right? You're on stand-up talking to each other about, let's get the problem statement right. Talking to each other about, let's get the principles right before we write code. And I have several linked examples. People are going to tell you not to do this. They're going to tell you, you don't have time for design. We're Agile, we're moving fast, we don't have time for design. They're going to tell you that your design and code will get out of sync, that this is another artifact like documentation that you can't trust. And they're going to tell you that Agile just makes design. These are all fallacies. The no time for design argument is and always has been ridiculous. The gas pedal makes the car go faster, but when you need to get somewhere in a hurry, you have to do more than use the gas pedal. Right? You might need to book an airline ticket. You might need to consult a map. At the very least, you should steer when you see the swimming pool. With regard to design artifacts getting out of sync, this is again update in place thinking. Nobody looks at their Git repository and says, my code from a year ago is out of sync with my code now. They say instead, my code has evolved over time. And nobody looks at their Git repository and says, this piece of code has gotten a lot of attention, and this piece of code didn't need much attention, so I have to give it more attention just to be fair. Right? You can do exactly as much design as you need, and you can maintain the history of it. Emergent design is almost a contradiction in terms. Design is a verb. It's an activity. Design does not emerge out of anything. And when faced with a design problem, naive Agile is just monkeys pounding on keyboards. Story points, stand-ups, retrospectives, pair programming, all have their place, but without design, you could never iterate your way from, let's say, Subversion to Git. Right? That transition took design. So, am I saying that Agile is bad? Absolutely not. I love Agile. I've built a business on helping people do things in an Agile fashion. Agile puts people first. Agile makes people talk to each other. Agile has self-correction built in. And Agile designers tend not to be ivory tower. They tend to be people who can and do write code. These are all good things. Evolutionary architecture incorporates a ton of practices that make it possible for you to change your software. And when I told that story before about the work on the error messages in Clojure, after we had done all that design work, we still ended up iterating on 25 patches before we actually got the code that finally went into Clojure. And that was easily recognizable as typical Agile stuff. Right? Submitting patches, looking at patches, assessing patches, pointing out problems. And that feedback loop went back to the design. In those 25 patches, there were 2 places where we hit head scratchers and said, you know what? We're going to go back and modify the problem statement because we've learned from the process of writing the code. So in short, Agile is great. Agile makes change cheap. And that's a big win because everyone has lived with fragile, brittle, monolithic software that can't be changed. But design lets you make valuable changes. Once you have the ability to change quickly, how are you going to use that power? So prioritize design. Add design activities to your Agile workflow and not just as window dressing. This is not a box to check. This is the most important part of the process. If you think pairing on code is valuable, pairing on design is infinitely more valuable. Prioritize design, and real agility will be your reward. Thank you.